So in second law we will discuss about the different statements of the persons, as the first law has some limitations which was not clearly explaining the all phenomena of heat transfer from one body to another. Here we've been discussing, and we will discuss about various statements given by different scientists in reference with the second law of thermodynamics. So first statement is nothing but the Kelvin statement, and he says that it is impossible to obtain a continuous supply of work. He says that it is impossible to obtain a continuous supply of work from, or we can say, by cooling the body at a temperature that is below the coldest of its surroundings. Means, let us consider a body, and that temperature of that body be T, and the surrounding is at temperature T naught. So in order to obtain a work by this object, we are just cooling it down. But the condition is, as the cooling is done, the moment it reaches to the coldest point, means the surrounding can go up to some very cold situation, that is, let it be T naught dash. So cooling the cooling the body below T naught dash cannot give you work on this object. For understanding this situation, let us consider a engine. Let us consider a engine. What does engine do? Basically, it takes heat from the source. It takes heat from the source, converts uh, this heat into mechanical energy, by which the bikes, the different vehicles run, and the rest is sent to the sink. So this is the phenomena of transfer of heat, and during which some part of heat is converted into mechanical energy and the rest is uh, been thrown to the sink. So this also explains that there is always some sort of heat that is converted into mechanical and rest is sent to the sink. But can you explain, if there is the source be at temperature T and sink is also at temperature T, so there is no heat flow, and initially let it be T1 and T2, where T1 is greater than T2, the heat of which is carried by the engine and converted into mechanical energy, and this, after converting into mechanical energy, the rest or the rejected part is sent to the sink. But what if the temperature of source and sink be same? What if the temperature of source and sink be same? There will no be difference any of any temperature. So if there is no temperature difference, no transfer of heat, and since no transfer of heat, no mechanical energy could be converted. So by this we can say that uh, as per the Kelvin statement also, that there is almost no work is done in this case when T1 is equals to T2. We can say that whole of heat can never be converted into heat work. Means all the energy, all the heat, complete and heat cannot be converted into work. Some of part will always be getting rejected. So we can say that a heat engine can never be 100% efficient. Means we cannot construct a heat engine, we can say a perfect heat engine that gives 100% output as about the heat provided, which converts all of the heat energy into the work. Some of the part of the heat will always be getting rejected. We can reduce the output, the rejection, the emission, that is the sending of heat towards the sink. But what we cannot do till now, that we cannot create 100% efficient heat engine that perfectly converts all the heat energy towards the mechanical work. So similar statement was also given by Clausius, and what does he said about, and what is the statement about this concept as per Clausius is